Hi everybody, this is Michelle, co-author of Methylation Madness, Insight into the Biochemical and Personal Lives of Hypermethylators. I have been asked to create a video about serine and the hypermethylator, and I am honored to have Dr. Terence Dulin, my favorite person, to do some real great explanations of this topic. So, Dr. Dulin.
All right. Serine is an interesting concept here. It works for you on a number of different reasons. Why?
Me particularly?
Yeah, and you particularly. First, we have to discuss what hypermethylation really is.
Yeah.
Hypermethylation has so many different things. It's not MTHFR. That's not hypermethylation. That is recycling of homocysteine back to methionine. Methionine is the main methylating compound in the human body. When it is active, methionine turns into S-adenosylmethionine via ATP and energy. S-adenosylmethionine is then your active methylating unit. It passes that methyl group, carbon with 3 hydrogens on it, to any number of different enzymes and stuff. People have basically talked about COMT, that's one of them, but there's also HNMT, PUMT. There's quite a few different enzymes that require methylation donation from methionine.
Is that, like with me, the CBS gene too?
Well, we'll get there. Okay. So S-adenosylmethionine does what it does, and as it gets rid of that methyl group, it becomes S-adenyl homocysteine, and then S-adenyl homocysteine is converted into homocysteine. Now, homocysteine can take 2 paths from here. It can either be metabolized down and out of the system, or it can cycle back up to methionine.
Right.
Now, the definition of hypermethylation is when that homocysteine keeps going back up to methionine and keeps going around in a circle over and over and over again. If the methionine keeps going to homocysteine, the homocysteine keeps going back to methionine, you're not removing it, and that's going to cause you to have too much methylation in your system, otherwise known as hypermethylation.
Just goes around and around.
Yeah, stays stuck in that spot. Now, before we get into what serine does and everything else, when you're hypermethylating like that, methylation takes the ATP out of your system. So you know that when things happen to you and it's in the hyper stage, you're tired and wired.
Yep.
Why tired and wired? Well, because all the ATP is being drawn down to activate the methionine over and over and over again.
And ATP is?
Adenosine triphosphate.
Right.
It's one of the main energy molecules. It's also what you would call part of your genetic material. Okay, it's manufactured in different places. It's made in basically your what they would call cytochromes. Okay, yeah, where it produces from your food ATP. Okay, then it's also made in your genetic material in something called purines. Purines is another place that ATP is manufactured. They do different things, they work in different spots and such, but they're basically the same exact compound. So when the methylation is in hyper mode, it keeps pulling your ATP off. As it keeps pulling your ATP off, your body and everything starts to feel tired, but because the methylation is in such high function, the enzyme PUMT, phenyl methyltransferase, changes noradrenaline into adrenaline. So your adrenaline is firing like crazy.
Yep.
So now you're tired and wired, which feels like temper and can't sit still and got to keep in motion and everything.
But exhausted
going,
at the same time.
but so tired. It also leads to moments when you don't have enough ATP in the system. And those are those lovely moments when you feel like somebody unplugged you, and if you don't close your eyes, you're going to drop dead.
Kind of like when I just got home today from work.
Yeah. When that happens, it's because the ATP took a dip. And that means your methylation chemistry and everything shut down for that brief moment. You need to close your eyes for like 5 minutes or so, and then all of a sudden, you're back wide awake and ready to rock and roll in a short period of time. As the ATP mechanism gets worse and worse and worse, what eventually happens is you run out of ATP more often, and now you spend more time in the extremely exhausted, tired mode, but now you're angry about it on occasion.
Is that more like a Gilbert's person? That they're dipped down more?
Well, it can be. Gilbert's is a different concept for other genes and things that are added into the mix. There's a UGT1A1, there's all kinds of things that come around with Gilbert's.
Okay.
But just discussing from the methylation standpoint, just the chemistry of that chronic cycling is why the energy goes up and down and up and down and doesn't remain stable.
Nope.
So this is where a lot of people with hypermethylation don't understand why their brain is wired and running 100 miles an hour, but they're so exhausted they can't get up and do anything. All right, so that's the ATP portion we're talking about.
Okay.
If you have a problem producing ATP, and there are different genes that go with that, ANPD1, there's all kinds of different segments that you can look at. If you do not produce enough ATP, then you get what is called the sputtering effect. All right? The methionine won't activate, then all of a sudden it'll activate like crazy, and you'll get a burst of explosion of energy, which in essence can lead to panic and everything as it goes up and down very rapidly.
Is that what used to happen to me?
Yes.
With the panic?
Yes.
Okay.
Okay. So this mechanism going round and round and round is hypermethylation. When it gets to homocysteine, going back to that circle we were talking about, there's two ways that it can be removed. One is to be recycled back up into methionine, and that's where MTHFR, MTRR, MTR, and MTHFD1L all come into play.
Okay.
Okay? The other pathway that takes the homocysteine back up to methionine is something that involves betaine. Betaine, otherwise known as trimethylglycine, okay, basically can cycle the homocysteine right back up to methionine, irregardless of what your MTHFR is doing.
Okay.
It's a safety valve. It's been discussed a lot by Yasko in her work with autistics and such. It's a secondary piece. It also has a lot to do with gut health, because betaine favors certain types of bacteria in your gut that are beneficial for you. So it has a lot to do with a lot of different systems. But those are the two that recycle it and continue the hypermethylation. Now, the other pathway where homocysteine can be removed is to go down into something called cystathionine and cysteine.
Okay.
Okay? Cysteine is another amino acid.
That's good for your hair too, right?
Well, it can be. It's part of your hair. It's one of the things that's found in there as part of the amino acid protein sequence. But cysteine and cystathionine are made from homocysteine. This is where your CBS and CTH genes come in.
Okay.
If you have a variant there, you can't get the homocysteine to drop out into glutathione, your antiviral, your immune system, all of those pieces. It stays stuck. The only other way your body can get rid of it is to dump it out as hydrogen sulfide gas.
Right.
Okay? Sulfuric acid. That's why a lot of people who have hypermethylation end up with stomach acid problems, GERD, and basically reflux. All of those things are from this never-ending dumping of sulfuric acid into the intestinal tract.
So back 30 years ago, when I came to you, I had severe stomach issues.
Right.
I was, like I said in the book, I was like dumping down
Right.
Mylanta. Now it's not like that anymore.
Right.
But sometimes, if I'm nervous perhaps, or I ate something a little bit off, right away my stomach hurts.
Right. And that would be equivalency of a couple of different things. There is also histamine levels that have to do with that.
Yeah, that's
histamine turns on H1, H2 receptors in your stomach and the parietal cells and causes acid production.
And my histamine is a lot lower from when I first started.
Right. Histamine is a lot lower, and you don't have the sulfur dumping into the bowel to make you all acidic.
Right.
Okay? So there's a lot of extras that go into that, and that's for another discussion.
Okay.
We'll talk about adrenaline and histamine balance and those pieces later.
So much to talk
We'll do
about.
another video for that. But now we get to cystathionine, okay, through from what you would call homocysteine. To do that requires that your body turn around and use the amino acid L-serine and B6PO4. Okay. L-serine bonds with what you call it, homocysteine, and becomes cystathionine if your CBS gene is working properly and you have B6PO4, which is a active form of vitamin B6, and water. You have to have all of those components present at that moment and that enzyme okay, which is basically called cystathionine beta synthetase. Okay, you have to have that all functioning, working at the same time for homocysteine to be removed correctly.
Okay.
Okay, if you don't, then that pathway runs at a sluggish rate, not off. Genes are never 100% off. They are sluggish, they work at a reduced rate, a certain percentage, okay, less than they should be, but they are never off. That is not conducive with human life. You have that gene off, you end up with a genetic disease, and that's usually short-lived. Okay, so the CBS gene makes cystathionine. Cystathionine then goes down and makes cysteine. That's the CTH gene. The CTH gene requires also water, okay, and it dumps nitrogens into the system. So there's a lot of different things that go on in this pathway here. The serine is one of the main ways to get that homocysteine to drop and push it out. Is that the only pathway? No. Serine also does something else. Serine, when it exchanges between it and glycine, uses a gene called SHMT. That's this guy here.
Yep.
Okay. That takes N5 and 10 methylene tetrahydrofolic acid and recycles it back up to tetrahydrofolic acid, bypassing methyl tetrahydrofolate, bypassing the MTHFR gene, and completely going to cycle the rest of the system back through the folic acid path. So it's integral towards two ways of getting rid of homocysteine and correcting part of hypermethylation. So that's the good sides of it. Now, bad sides of it. Serine, as it blocks and pulls the homocysteine out, stops the recycling back to methionine. So methionine now does not pick up ATP, does not become S-adenosyl methionine at the same rate. It does it a lot lower. And in doing it a lot lower, there's less methylation in the system, which sounds perfect, except methylation, okay, is also required to activate PUMT, which changes noradrenaline into adrenaline. Adrenaline balances histamines. So people with bad histamine problems have to be very cautious about serine because it will allow the histamine levels to react more in the system. So you have to be careful with it, and you have to really know what you're looking at in your own chemistry and genetics before you just toss that out there. Okay? You just don't throw serine in. Now, what's a safe way to put serine in to see if you're going to have that problem? Coconut. Coconut has a higher percentage of serine than other foods does. And it's lower in amino acid sets so that it reacts more. So you're going to get a reaction from eating lots of coconut, lowering down your methylation. If you have a histamine problem, eating coconut will make your histamines worse. Not because you're allergic, but because it's blocking the adrenaline histamine balance. And if it blocks adrenaline, it blocks that balance, and now you're going to have more allergic reactivity. So these are the things that you have to look at.
Would you have called me a person with a histamine issue back then or now?
You have a histamine issue because you have a methylation problem. When you have a methylation problem, it tends to focus on certain enzymes that it predominates. So one of the ways you get rid of histamine in your body is HNMT. It's an enzyme called histamine methyltransferase. Mm-hmm. It basically needs the SAM, S-adenosyl methionine, to activate it, and then it lowers your histamine levels down. Mm-hmm. Now this is different than the enzyme AOC1, which is the genetics that control the production of diamine oxidase. Diamine oxidase is an enzyme that breaks down histamine in your stomach and intestinal tracts. It's not really that prevalent in the rest of the body. It's there, but it's not that prevalent. Okay. So the histamine levels for you, because your methylation was so firing all the time, remember, histamine and what you call adrenaline have to be in sync with each other. If one goes up, the other one goes up. If one goes down, the other one's supposed to go down. If it doesn't go down, you end up with more of the allergic symptomatology. That's one of the issues with L-serine, why you have to be very careful how you use it.
Is that why sometimes I get like super, super itchy when my histamines are high?
Yes.
Okay.
Histamines
Right.
cause vasodilation in your skin,
Yeah.
which will give you a crawling feeling all over it,
It's great.
and kind of just make you feel like ants are everywhere.
Awesome.
You know, it's good for a weekend.
So really fast again. You said that it'll shut it down. So when I
Not shut it down, it'll lessen its
Lessen.
function.
so when I
Remember, these enzymes are going 10,000, 15,000 mechanisms per minute. These are really flying all over the place.
Right.
Chemistry is not static. Chemistry is always in motion. It's always moving. So when you're looking at a chemical mechanism, it's moving, but how fast is it moving and how much is it balanced against other factors? That's what you're really talking about with genetics and biochemistry inside the human body.
So when I used to get the severe anxiety attacks, I would eat a coconut macaroon or 12, or take a serine, and then it would just bring me right.
Right. What it would do is block the methylation,
Right.
so that the methylation stopped. Okay, slowed down and pushed everything out. Going through CBS gene and CTH gene to cystathionine and cysteine. Cysteine is the main chemical that's used through a number of other steps to make glutathione. It requires glutamine, cysteine, and a couple of other amino acids thrown together. That pathway for glutathione is antiviral, which is why a lot of times viruses are very difficult for hypermethylators to get rid of. They're good, real good, okay, with fighting stuff off as far as bacteria and stuff. They don't usually get a lot of those illnesses. Viruses, not so much. If the glutathione is not working correctly, you're going to have problems with that, and you're going to have problems with detoxification. Both of those become a problem. Serine will slow detoxification because it will slow the COMT enzyme, which is part of phase 1 and 2 detoxification in the liver. Okay, if you slow it too much, you get toxic. So you have to really make sure that you're keeping your diet stable and you're doing the correct things as far as food, not putting in chemicals, and keeping that clean pathways as much as you want, you can possibly do. The problem is that a lot of people think the word clean means don't eat this, don't eat that, like there's dirty food. There's no such thing as dirty food. There's food that works in you or food that doesn't work in you. This is a concept everybody really needs to think about. If you're eating food that's loaded with chemicals, it's probably going to give you cancers and everything else. If you're eating foods that not have chemicals, like organic and such, you're going to have less problems with toxins. And that makes the serine pathway much easier to use and much easier to work with to correct hypermethylation. If you can get the enzymes to function at a higher rate by providing the substrates, you can bypass the negative effects of the gene. Completely? No. There is no way you can correct a damaged gene unless you have a CRISPR kit and you're willing to take the chance that you're going to kill yourself. Okay? So the point comes down to is that you're bypassing the gene by to make it the easiest way to think of it, you're supersaturating an enzyme. In other words, let's say the enzyme is only working 25% of normal. Okay? Genetically, that's all it can produce is 25%. But you got a lousy diet, this, that, and the other thing, so the 25% drops to 10%. Now the enzyme isn't working that well. When you add serines and things, B6 and water, what you're doing is giving it all the substrate so that it can all the way back up to 25%. Is it going to go above 25%? No. Can't go above 25%. The enzyme is controlled by the metabolism from the genetics. The genetics say 25% is what you got, that's all you got. Now, what does that mean long term? No garlic. It means that you can eat these foods eventually as the system kind of stabilizes itself out, but you cannot put them in on a regular basis and just do anything you want.
Builds up.
It'll build right back up, and then you get explosions. And you're going to get symptoms returning. Okay? So you can't correct the genetics, but you can compensate for them and bypass them, which is why some people don't eat anything they're not supposed to eat because it doesn't feel good. Okay?
Yeah, but I would feel if I ate garlic or onion or you know, if I was off on my fish time, which I'm almost ready for that, within 20 minutes. 20 minutes, I feel something immediately.
That's the enzyme jamming up. And this is why dietary work becomes so important and not just supplements. Okay? Eating a little bit of coconut every day will be effective at helping cut down your methylation. Putting a lot of coconut in or putting in a ton of serine will basically jam the system up, and you're going to have reactions. So you have to be very nuanced and careful when you're playing with your own body chemistry.
That's why I, on my program, it's a tablespoon of coconut milk ice cream.
Right. It's depending on what's going on, you have to know how much your system can use. Now it varies on a number of different things. People don't realize it, but everything you put in your mouth does not get into your bloodstream. That just does not happen. Human digestion is about 25 to 40% effective. So when you eat something, you're going to get about 40% of that on a good day, 25% of that on a bad day. Okay? Now, are you having a good day or a bad day? Don't know. Are you having a good meal or a bad meal? Don't know. So you can't specifically put it down to the absolute, this is going to absorb that. Just does not work. Everybody's digestion runs at a different day. You may be at 40% for breakfast, 32% for lunch, 28% for dinner. You may be 28% for breakfast and 40% for dinner. You do not know. That's why you have to look at things over a course of time. Time is the important factor here. Okay. The chart that's in the book will explain the folic acid and the serine pathway. It's a bypass. It's a bypass. It will basically help move things along more rapidly and fix things better if the right circumstances, like in Michelle, exist in you. Then it'll work. Just tossing it in because you're a hypermethylator, I'm sorry, a lot of you guys don't even know what hypermethylation really is. MTHFR is not hypermethylation. MTHFR is not hypomethylation. MTHFR is a recycle mechanism. Where does the majority of methionine come from? From recycling? No, it comes from your diet. Okay? Which is why a lot of vegetarians have a problem with methionine, because it isn't found very high in a lot of foods, and they end up being deficient, and they become hypomethylators because of dietary rules. So diet makes a big difference. If you're eating tons of methionine foods, like let's say you're a Pacific Islander, and the majority of what you eat is fish, okay? If you keep doing that, you're going to keep pumping up the methylation cycle, and you're going to make yourself a hypermethylator, which gives you temper and everything else, which I think the Pacific Islanders were kind of known for. Might have been. Okay, but these are the kind of things that happen over time when you're looking at it. Okay, why was coconut the main thing on those islands? So they didn't kill each other. So coconut and fish went together there. That was the environment that kept things more stable. Okay, and they would use tons of coconut in addition to the seafood. The serine and the methionine would balance each other out.
So when I eat, I don't look at it as it's a string bean and it's a piece of chicken and it's a potato. I look at it as what the biochemistry of each of my foods are. I think I did a video once on that. And this is how I think, because I'm constantly balancing my chemistry.
See, hers is a little different because of the CBS-CTH gene, along with some of the other folic acid problems. Her system has some major issues also with COMT and MAO. When you add those two genes in, you're going to end up with improper removal, jam-ups in the system, and if your COMT is only functioning at 65% or 25%, okay, your methylation is going to have to go someplace. Mm-hmm. So it'll go to other enzymes in other parts of the body. Methylation chemistry is also responsible for hormones. It breaks down hormones in the system. It's also responsible for the histamine removal. It's also responsible for adrenaline production. It also breaks down neurotransmitters. Serotonin, dopamine, norepinephrine, epinephrine, okay, histamine are all broken down by methylation chemistry. as part of their removal. The other part is MAO. Okay, so this is a very complex piece, and to just toss things in gets very dangerous. So you have to be very careful how you do it. If she was to eat too much coconut and put a ton of it in, you'd probably find her sleeping for a long period of time and not able to basically do anything, just be too tired to do anything.
That's even if I have, a larger bit of coconut ice cream, guaranteed within 15-20 minutes I will be knocked out for about 10 minutes, and then I'll be up like wide awake.
That, as the serine pulls out the excess methylation and dumps it out of the system. And that's also when you get a high degree of dumping of the hydrogen sulfide, as hypermethylators do, your bowels will tend to turn yellow. Why? Sulfur. Sulfur gets dumped into there. It will give that wonderful rotten egg gas smell. It will turn around and change the color of the bowels lighter and lighter towards a yellowish or tannish color.
And that's what happened when I had liver failure.
The liver failure came about because they gave you a basic drug you could not metabolize, and it was sulfur-based, and you can't metabolize sulfur well. So the combination of those two is basically why you nearly got killed.
Why what?
You nearly got killed.
I almost, sure did.
Yeah.
But I'm here because of you.
Well,
question. A lot of people mention the fact that they want to, they're looking for a detox. They're looking for different detox because they have MTHFR.
Well, the question comes down to is, what are you detoxing?
Right.
The term detox is basically an overused term. It doesn't really mean anything, okay? Your liver is always detoxing. That's what it does. That's what the organ is designed to do, is detox. Now, sometimes when you look at detox, as a lot of professionals will say, oh, you need to detox. What they're saying to you is you're overly toxic because you've overstretched your detox system. They're not saying that you can't detox. If you couldn't detox, that's not really conducive with life, period. So when you're looking at detox things, what are you trying to get rid of? You're trying to get rid of what? Sulfur? You're trying to get rid of, methionine? You can't detox them out. That's not something that happens.
People see that they have the MTHFR gene and their methylation system is all messed up, so they feel that they need to detox. But I say that
The question is, what are you going to detox?
And I say it's not that you have to detox, it's the fact that you have to get your methylation chemistry working so your liver and your body detoxes properly.
Yes. And that makes more sense than thinking that because you have MTHFR, you're toxic. MTHFR does not make you toxic. MTHFR is nothing more than a gene that controls the change of N5, N10 methylene tetrahydrofolic acid to N5 methyl tetrahydrofolic acid. That's it. That's what it does. Now, you're going to see a lot of genetics, and you're going to look at a lot of genetic, what we call cut and paste jobs, where they're going to cut and paste MTHFR information and put it on a piece of paper and tell you this is what it is. You're going to die if you have it. No. Most of the genetics at this point are not really heavy into chemistry. They're more into drug metabolism and drug effects. So when they look at a disease, medically, you look at, well, what do these people have in common? So if they all happen to have an MTHFR, they're going to say, oh, that's the one that's in common, and they're going to associate it with that disease. That does not necessarily mean that that's the cause of that disease or anything else. It just means that I ran a lot of tests on a lot of people, we did a study, and this is what we found. That's all it says. To give you an example, I have a patient, and she keeps sending me an HT2RA gene and saying, oh, look, I can't take selective serotonin inhibitors. It says so right here, so I can't touch serotonin. No, that means you can't touch the drug. The drug does not work well with that gene. However, there are tons of other genes in there that the drug is not going to affect. But that doesn't mean you can't take something that makes serotonin. That would mean if you ate a turkey sandwich, you're going to die. And that's not true. So you have to look at the genes and the way things go. Sulfur and methylation chemistry is very complex. It requires a lot of different balancing agents because it basically does a lot of different things in a lot of different systems. Okay? What methylation is simply moving a carbon atom with 3 hydrogens from here to there. That's it. That's all it does. That's nothing more. Now, when you put a carbon atom on another molecule, you change that other molecule's function, you change what it does and how it does. You also change how the body can address it. Put another carbon on it, maybe you can add an oxygen now or a water group, and that allows it to be pumped out of your system and detox correctly. That's detox. Okay? When you're looking at it from the standpoint here, you're looking at serine as a way to lower down methylation hypersensitivity really fast. Okay? That's what you're looking at. Pumping it out of the system quickly. Does it have side effects? Sure. The histamine levels can go through the roof. You have to be very careful that you don't have a histamine problem and that you're on a low histamine diet. If you use serine with a high histamine diet, you will have allergic reactions all over. If you use serine without having very high methionine hypermethylation going on and just an MTHFR gene, you can actually cause hypermethylation by eliminating out the CBS gene and tying it up. Okay? Serine also, if you take too much of it, serine makes the amino acid glycine. Now, glycine is another amino acid that does a lot of things. How is it involved in methylation? Glycine combines with arginine and S-adenosylmethionine. That makes something called creatine phosphate. Creatine phosphate is the main energy source for all your muscle tissue, which is why when it screws up, you know you get weak out of nowhere. Your muscles stop giving you that strength level and everything else that you're looking for. Okay. How does it feel? Does it feel like you're drained, or does it just feel like you're weak? What does it feel like?
It feels like I just can't lift like a water bottle. I just don't have the ability to do anything. Just nothing.
So serine, okay, can
great
be
feeling.
affecting that. Can be affecting that, okay, if it's moving in one direction. If you put the serine glycine combination in, it's going to go back and forth, and it's going to kind of change into all different things. The body does not allow one mechanism to stay one thing only. If it makes something from something else, it's going to use that. The body is incredibly good at salvaging anything and everything it can to make things work correctly. Okay? When you're dealing with serine, you have to remember about the glycine, because if serine turns into glycine really fast, that means it's going to activate the creatine phosphate, and that means methionine is going to go back into hypermethylation. And now the serine doesn't work. The serine turns around and actually makes you hypermethylate. Now you've got muscle cramps and your adrenaline's firing and everything's going crazy again. Okay? These are all the things you do see with hypermethylation. And using serine is very carefully planned out when you use it. You have to know and monitor what's going on in the system. Otherwise, you can run into all kinds of problems. Should serine be used forever? No. Okay? It should be used at different times when it's needed. Okay? The system's really jammed up, high methylation going crazy, use the serine. Is the person going to have side effects and things from it? Absolutely. They're going to get really tired, they're going to want to sleep more, they're going to feel exhausted. That's going to last about a week, maybe 2, maybe 3 weeks.
Yeah.
Then all of a sudden, that's going to go away as it shifts back to the glycine. But now you've pumped out enough of the methylation that was overloaded to clean that up. So now it's not as terrible and not as bad. And you start to feel a little better and a little better and a little better. You use serine, you get 3-4 months out of it, it's cleaning everything up. That, in most cases, takes care of it. Some cases, who have CBS gene malfunctions, no. They end up needing it more all the time. That's where the dietary factors come in, adding a little bit. Now remember, coconut, like every food on the planet, is multi-vectored. It's not one thing. It has all these other amino acids, all these other fatty acids, all these other chemicals built into it. So to try and take a food and make it a single item does not work. You have to remember that every food is multi-vectored. It's going to do 10, 15 different things. If the chemistry has a predomination of this or that, you can use it as part of a treatment, but you can't use it singly. It's not going to work.
So question, there are some hypomethylators that are friends of mine that you treat. And they've told me that on their program, you are allowing them some coconut.
Right.
So what would, like Olivia, she's a hypomethylator, no coconut.
Right. Certain ones, depending on other factors, are there. If I'm going to give a diet to a hypomethylator, I'm going to give a diet that has a very high amount of methylation in it.
That I just answered my question.
If you've got a ton of methylation coming in from the diet, you have to make sure that there's at least something there to balance that off, so it doesn't run out of control, and you don't take a hypomethylator and make them a hypermethylator.
Right.
That's where diet work, you have to be a little bit more balanced.
That makes, I knew that. I
knew you did.
I did.
But that's one of the things you're going to see with diet. Diet must be part of any treatment protocol. If it is not part of the treatment protocol, then basically you're not going to win. I will use my favorite line that I use for all my patients. Supplements are like generals. Food is like foot soldiers. Nobody ever wins a war with just generals. Gotta have foot soldiers. And nobody wins a war with just foot soldiers. So you've got to have both working together in concert with each other to make the system run correctly. Otherwise, they're not going to run. And you're going to have imbalances and fallouts, and you're going to have a rocky road going up and down and up and down and up and down. That's why diet becomes a constant. You get a diet, you stay on that diet constant. That eliminates variables. That stops things from bouncing. Now when you add the supplements, you're affecting specific pathways. So those specific pathways are going to accelerate or decelerate depending on what you're using with the supplement, but the diet keeps everything stable.
And I can say from my own experience that I'm 99% perfect on your diet because I just don't like how I feel without it. So I had COVID, then I had my ear infection, and I was saying to myself, wow, even with all of this, and I wasn't taking my supplements,
Right.
and I certainly wasn't eating the way I should by any means because I didn't have much of an appetite, but yet the percentage of me feeling how I used to feel was like 5%.
Because your system has been lowered down.
Right.
Your methylation, if it's up here and you bring it down here, gives you a lot more wiggle room.
Yeah.
That's basically why you could get sick, you could have this, you could have that, and you've got more wiggle room, so it's not a problem. Now, if she was to turn around while she was sick and decide that she was going to eat fish for breakfast, lunch, and dinner, okay, so drink lots of alcohol with methylating groups, that would immediately push it way back up and overstep the safety that's been built. Yeah. You have to get the enzyme to run, and you have to get that enzyme to run at a certain speed. Once you know what it's going to do, what speed it's going to do on a day-by-day basis, you know how much wiggle room you have. Chemistry, unfortunately, does not really care what you think. It doesn't care what you believe. It doesn't care about any of that. It goes from here to here, and that's it. That's what it does. You have to understand, if you can't metabolize something, and it's not going to work in your system because of your enzymes and other things, that is like trying to take a Ferrari and put the cheapest gas and oil into it you can and expect it to run 200 miles an hour.
I think that's in the book.
Yeah.
Or maybe we talked about it when we were writing it.
It might have been.
I remember.
You can't put things in. Now, if you put high-test gas and you put the best oil in that Ferrari, it runs like a top. But that means it's specific. Volkswagen does not need the same as a Ferrari. So you have to look at what your body's doing and figure out what you need and how you need it to find the right fuel. Once you have the right fuel, if you stay with that, then you can enjoy everything else in your life that you want. You're just not going to be the foodie person who can eat everything on the planet. And don't get me wrong, there are people whose chemistries are great who can eat everything on the planet and enjoy it and not have a problem. But that's not the audience we're talking to.
But I can say, I mean, I would definitely call myself a foodie, but I'm just a different foodie now.
No, you've
I've
discovered,
adapted my diet to make it the best I could possibly do.
and you've created your own tastes and things according to yourself and what you like. And that's what people really need to do if they want to have functionality and everything else. You can't correct a variant in a gene. It's no way you can do that. That's an impossibility. You cannot shut the gene off. What you can do is work around it.
With the biochemistry.
Right. You can work around it because basically the gene has a function. That function is at a certain rate, a certain percentage. If you know that rate and percentage, you now know how to order everything else. Same thing as if you were a sports guy. Okay, you play basketball. All right. You know you can't make a 3-point shot, but you know from foul line you can hit it every time. So does that mean you spend your day trying to make 3-point shots? No, you go to the line because you know that's where you're going to make the shot. Same thing with food. If you know that eating this is going to give you a problem,
Don't eat it.
don't eat it. Okay? Or figure out how much you can eat before you get a problem.
Yep.
How many people, I'm just going to take some Tums because my acid in my stomach is killing me. And now we find out that Tums cause all kinds of other problems. Okay? You're doing damage to your system by adding foods you cannot metabolize. That's putting leaded gas in an unleaded car. That's turning around and basically using kerosene in your oil burner. Okay, these things do not work well. They all burn, they all do stuff, but they do not work well. Okay, so you have to find the right dietary pieces that fit in your system and stay with that. And stop thinking to yourself, oh my God, I can't have this, I can't have this, I can't have this. Yeah, but if you don't eat that, you can run 5 miles, you can go upstairs, you can go out and have a good time, you can enjoy yourself, and you can function fully. Which is more important to you? That 2 minutes of joy eating it? Or basically turning around and having a great life every place else?
And like, you know, like you said, if your body is balanced, every once in a while, you can give a little bit here and a little bit there, but not on a consistent basis. I am living proof of that.
Right. See, we figured out that her methylation had dropped down enough that she could have a little methylating food, the fish. Okay? So, every so many weeks, we decided to put it in and see how it would work. Okay? When it was too close together, not good.
Felt awful.
Well, not only that, your temper went up.
Oh, yeah.
Your daughter called me and said, what the hell's wrong with Mom? Okay, so you see all of that going on and you understand that it's too close. So then we spread it out further. And guess what? Now she can metabolize it so she can enjoy it. She can metabolize it. It's not doing damage to the system. It's not hurting her body. She's not getting side effects. But at the same token, she knows how many times she can get away with it and how long.
It's like a present. It's like a biochemical present.
Well, it's the way people should enjoy things. It's like cake, okay? Cake is a great thing, but you don't want to eat it every day, all right? Why? Because you end up with diabetes, all right? Pure and simple. Now, why didn't that happen in the old days when Mom was making the cake? Because she only made the cake once a week, and you ate it on Sunday, and that was it, okay? You didn't have cake all week. Now, we have cake for breakfast. We have Pop-Tarts. We have donuts. So we're having cake for breakfast now, every single day. Is that healthy and functional? No. Same thing with any food that you have. If you can metabolize it, eat it by the bucket. If you can't metabolize it, restrict it down because it's going to do damage.
Yep.
Now, what does damage mean? Well, in this case, you're looking at folic acid. Folic acid is integral towards your genetics, healing, repair, rebuilding. It turns around and helps keep your cells young so that you don't end up with cancers and things of that nature. So if you turn around and you're beating this pathway up by putting in things you cannot metabolize, then you are eventually going to end up with all of these diseases. That's why we keep coming up with new diseases that nobody's ever heard of before, that just keep showing up and showing up and showing up. Metabolically, we're damaging our systems, and that creates a problem.
Well, Doc.
Anything else you wanted to discuss on this one?
No, I think they need to absorb your Dr. Dulin-ness.
Well, this is strictly biochemical,
Yeah.
and it's the understanding of how that applies to clinical. Okay, that's basically what we're trying to give you a little bit of. A lot of you want to just start treating yourself by reading a website or something else, or going on this and going. No, that's not really the safest and best thing to do. I'm not saying anybody isn't smart, okay? That's not the question. But let me ask you a question. Would you go in and try and fix a nuclear power plant because you read a book on it?
Nope.
I don't know, just thinking. Would you do that? Would you do open heart surgery on your daughter or your sister or your husband simply because you read a book on it? No. There's a lot more that goes into clinical practice.
Yes.
And doctors get a bad rap about all kinds of things, and some of it's deserved, some of it's not. Okay? Some of it is external circumstances, some of it's not. But the point comes down to, they went to school to look at all the different possibilities that you're not going to get unless you spend 4 or 5 years learning all of this. So don't just toss stuff in. Look at things, understand things, get a better knowledge of what you're doing, play with your diet. Sure, do all of those things.
But know if you're hypermethylating or hypomethylating.
Yes, understand what the terminology means.
Yes.
Okay.
So many people don't even know the term hypermethylate or hypo.
Well, it's a term that's really not related to MTHFR, but it got thrown onto it. Methylation chemistry is folic acid. No, it's not. It's a recycle mechanism. Methylation chemistry comes from methionine being activated to S-adenylyl methionine, and most of that comes in from your diet. That's where you're getting it from. You're not getting it because of the recycle. The recycle mechanism is important and needed, yes, but the diet is what supplies the amino acids. Those amino acids are found in your proteins. That's what's driving your system, which is why the recycle mechanism doesn't work if you don't eat. If you don't eat, you die. Why? Because you don't have the things to add to the mechanism to keep it running. That's the issue.
All right. So you can find our book, Methylation.
She's
Methylation.
plugging the book.
I'm plugging the book. Methylation Madness: Insight into the Biochemical and Personal Lives of Hypermethylators on Amazon and BarnesandNoble.com. It is a wealth of information in written form about.
It's also more of a clinical understanding.
Yes.
It's not just the biochemistry, but how it relates to systems and what kind of things happen in the systems.
And there are 4 personal stories in there, mine included, about hypermethylators. So thank you, Doc.
A pleasure. And we'll do another one, and we'll talk about the histamine adrenaline balance, and we'll talk about histamine and its breakdowns and things of that. We can do that. But there's a couple of other ones that people have asked her about. I have no problem with doing that.
Great.
Okay.
Thanks, everybody. Hope
Have a
you
great
enjoyed
day.
it.
Bye-bye.
Bye.